The Milky Way, a cosmic lullaby. Soft, contemplative narration. Close your eyes and imagine yourself lying beneath a blanket of stars on a warm summer night. The air is still, crickets chirp softly in the distance, and above you stretches an ancient river of light, our home, the Milky Way. We live inside a cosmic island, a magnificent spiral of 400 billion suns, each one a world unto itself. Our galaxy is so vast that light itself, traveling at 186,000 miles per second, takes 100,000 years to cross from one edge to the other. To truly comprehend this scale, imagine that if our sun were the size of a grain of sand, the Milky Way would still stretch across the entire United States. The name Milky Way comes from ancient Greek mythology. The Greeks saw this celestial band and imagined it was milk spilled across the heavens by the goddess Hera. Cultures around the world have their own names for it. The Chinese call it the Silver River, while the Kalahari Bushmen of Africa know it as the backbone of night. Our galaxy is shaped like a cosmic pinwheel, with graceful spiral arms that curve outward from a brilliant central bulge. These arms aren't solid structures but rather density waves, like ripples on a pond, where stars, gas, and dust congregate. We've named these arms. There's the Perseus arm, the Scutum Centaurus arm, and the Sagittarius arm. Our own sun resides in a minor arm called the Orion Spur, tucked between two major spirals. Picture our position in this vast wheel. We're located about 26,000 light-years from the galactic center, not in the crowded downtown of our galaxy, but in a quieter suburban neighborhood. This location is remarkably fortunate. Too close to the center, and deadly radiation would sterilize any planets. Too far out, and there wouldn't be enough heavy elements to form rocky worlds like Earth. The heart of our galaxy holds secrets both beautiful and terrifying. At the very core lurks a supermassive black hole named Sagittarius A star. This cosmic monster contains the mass of 4 million suns, all compressed into a region smaller than Mercury's orbit. It sits there, silent and invisible, yet its gravity orchestrates the dance of billions of stars around it. Our entire solar system is in motion, orbiting this galactic center at a breathtaking speed of 514,000 miles per hour. Yet even at this tremendous velocity, it takes us 225 to 250 million years to complete one orbit, a period called a cosmic year. Since Earth formed, we've only completed about 20 orbits around our galaxy. When dinosaurs walked the Earth, we were on the opposite side of the galaxy. The Milky Way isn't alone in the darkness. It has two small companion galaxies that orbit it like loyal satellites, the Large and Small Magellanic Clouds. These dwarf galaxies are visible from the southern hemisphere as fuzzy patches of light. They're being slowly torn apart by our galaxy's gravity, their stars eventually destined to join the Milky Way itself. But there's an even grander cosmic drama unfolding. Our galaxy is on a collision course with our nearest large neighbor, the Andromeda Galaxy. Don't worry, this collision won't happen for another 4 billion years. When it does, the two galaxies won't crash like solid objects. Instead, they'll pass through each other in a slow-motion ballet lasting billions of years, their stars and gas clouds mingling until they eventually merge into one enormous elliptical galaxy. Some astronomers have already named this future galaxy Milkomeda. Between the stars lies not emptiness, but a thin mist of gas and dust. This interstellar medium is the womb from which new stars are born. In certain regions, vast clouds of hydrogen gas collapse under their own gravity, heating up until nuclear fusion ignites and a star is born. The Milky Way creates about 7 new stars every year, some much larger than our Sun, others much smaller. The most massive stars live fast and die young, existing for only a few million years before exploding as supernovae. These explosions scatter heavy elements, carbon, oxygen, iron, gold, throughout space. Every atom in your body, except for hydrogen, was forged in the heart of a dying star. We are, quite literally, made of stardust. Our galaxy is also home to some of the most exotic objects in the universe. There are neutron stars, the collapsed cores of dead stars so dense that a teaspoon would weigh 1 billion tons on Earth. Some of these spin hundreds of times per second, sending out beams of radiation like cosmic lighthouses. We call them pulsars. The disk of the Milky Way is incredibly thin compared to its width. Imagine a pancake several miles across but only as thick as a coin. This disk is where most of the star formation happens, where young, hot blue stars illuminate clouds of glowing gas in spectacular nebulae. Rising above and below the disk is the galactic halo, a spherical region populated by ancient stars grouped in globular clusters. These clusters contain some of the oldest stars in the universe, born when the galaxy itself was young, over 13 billion years ago. They orbit through the halo like bees around a hive, their stars so tightly packed that in their cores, stars might be only light weeks apart rather than light years. The Milky Way has a warped disk, bent and twisted like a vinyl record left too long in the sun. This warping was likely caused by gravitational interactions with our satellite galaxies. The disk wobbles as the galaxy rotates, a cosmic imperfection that makes our galaxy even more interesting. Within the galactic plane, there are regions so dark that they appear as voids in the sky. These are not empty spaces but dense clouds of dust that block the light from stars behind them. Astronomers once thought these dark patches were actual holes in the heavens. Now we know they're stellar nurseries, where the next generation of stars is gestating. Our galaxy spins differentially, the inner regions rotate faster than the outer regions, like a whirlpool. This rotation creates shearing forces that help maintain the spiral structure. If the galaxy rotated like a solid disk, the spiral arms would wind up and disappear after just a few rotations. The night sky we see is only a tiny fraction of what's out there. Most of the Milky Way's mass isn't in stars at all, it's dark matter, an invisible substance that we can only detect through its gravitational effects. This dark matter forms a vast halo around the visible galaxy, extending perhaps 10 times farther than the stars themselves.